Okay, today we're going to be doing families of functions, and there's quite a few of them. I'm actually going to be using four different highlighters today, so make sure you're ready with that. So as we said, we're going to be dealing with families of functions. We're going to actually be going over four different types of functions, and we're just going to give you brief examples of what they look like, okay? So first one we're going to do is a linear function. A linear function has the form of f of x equal to f of x equal to mx plus b. Sorry, I got lost a little bit. Um, so yeah, you should have seen this last year in eighth grade. Again, this year in ninth grade, like that's going to be pretty standard. We're going to be using it quite a bit. Okay. So how do I know if it's a linear function? Well, I know that the exponent of the variable is going to be 1. So for example, right here, here's my variable. There is no exponent, so I know that it's an imaginary 1 up there. And when we do stuff like this, it ends up looking like a line, right? With the slope and everything. So what are they going to look like? They're going to look like this. Notice that on all of these, the exponent is 1, the exponent is 1, the exponent is 1, because we imagine that it's not there, okay? Or when it's not there, we know that there's an imaginary 1. All right, let's go ahead and start filling out the table. Just because this is going to take a long time to do, again, there's 4 of these things. I'm not going to fill out every single table. I'll show you like 2 examples on how to fill this out. And then from there, you're going to go ahead and do the rest, okay? So I want to plug in my x value of -2 everywhere I see an x, which in this case is going to be here. So I'm going to replace that x with this number, -2. Remember, when you replace a number, you replace it with parentheses. So let me go ahead and replace that -2. This is going to be y is equal to -2 times, there's my x. I'm going to replace it with, in this case, my -2, and then add the 1 at the end. -2 times a -2 is going to give me a +4 plus 1, which gives me a 5. That is to say, when x is -2, the y value is 5. So let's go ahead and plot that on my graph. -2 comma 5, I get a dot that goes right here. And we're going to move on to the next one. On the next one, it's going to be -1 when I'm plugging into my x value right there. So let's go ahead and do that. I'm going to plug in y equals -2 times, there's my x. I'm going to replace it with a -1 this time, plus 1. -2 times -1 is a +2, plus 1 is going to give me a 3. So when I plugged in an x value of -1, what popped out was a +3. So I'm going to fill that in my table. And I'm going to go ahead and plot that. -1 comma +3 should be right here. Again, I'm not going to do all the points, but hopefully you kind of get the habit of what we're supposed to do. I'm going to replace the 0 on my x, and when I do that, I get a 1. When I replace the 1, I end up with a -1, and when I replace the x with a 2, I get a -3. If I plot those points, I get 0, comma 1, 1, comma -1, 2, comma -3. And I want you to take a look at what's happening here. It looks like I'm getting a straight line, and that's exactly what's going on. So I need you with a ruler to go ahead and connect all those dots and make sure that you get a perfect straight line going all the way across. So with that, I should be able to answer some of these questions. The first one is, the graph is going to be a straight line. I really want to emphasize that. So to do that, I'm going to go ahead and highlight the word straight line. And we're going to actually highlight the straight line that we have going on right here. This does make a straight line on my graph. The graph has a constant, and we talked about this word, I think, earlier. It has a constant slope, which we use the letter m. And again, this should be review. If you look at the equation that we have over at the top, as far as my slope is going to be that number in front of the x, which is going to be -2. So let me write down a couple of things just to remind you. This -2 is my slope, which we use a letter m for. The slope is usually written as a fraction. So if we're going to write -2 as a fraction, I can do that by putting a 1 underneath. -2 is the same thing as -2 divided by 1. Why am I writing it like that? Well, because if you remember, when you do slope, this is your rise over your run. So a rise of -2 means you're going down 2, and a run of +1 means you're going 1 to the right. So whenever you get one of your dots, to go to the next one, you're going to go down 2, right 1, put a dot, down 2, right 1, put a dot, down 2, right 1, put a dot, and that gives you your slope, which gives you the rest of your line. Okay, just a little bit of review in case you forgot. The other stuff we're going to go through a little bit quicker. If your slope is greater than 0, so this number, if it's greater than 0, then we call it increasing. You have an increasing graph because your graph is going to be going up as it goes from left to right. That's not what we have. We have a slope that's less than 0, which is -2. So if your slope is less than 0, like us, then it is decreasing because, again, as I go from left to right, my graph is going down. Okay. If m equals 0, then we say we have a horizontal line. That's a really special case. So with a slope of exactly 0, you're going to get a line that goes straight across like this, as opposed to going down like the one that we have right now. And then the last one, if b equals 0, then we're going to pass through the origin. All right, so that's all the review for this first one. Let's go ahead and keep going to the next one. The next one, quadratic functions, we're actually going to hit up a lot in Math 2. You're going to see it a little bit right now, so let's go ahead and just kind of tackle it, but you're going to definitely delve way deeper into it in Math 2. So first things first, it's going to be a quadratic function. Let me go ahead and highlight that one in blue. A quadratic function is a function that has the form y equal to ax squared plus bx plus c. You know it's going to be a quadratic function because the exponent of the variable is going to be 2. That's this 2 that I'm talking about right here, okay? Sorry, I'm getting notifications. So if you notice all your examples, you have an x squared, you have an x squared, you have an x squared, right? That's going to be your biggest exponent. You're going to have a degree of 2. All right, as far as plugging this in, I'm going to take the -3 and I'm going to plug it in for my x. Everywhere I see an x, it's going to be replaced with the -3. So I'm going to write down this equation, but when I see the x, I'm going to replace those x's with -3s in parentheses. It's going to look like y equals negative parentheses. I see an x, so that x, I'm going to put parentheses, and inside I'm going to put a -3 squared minus 2 times, I see an x, so I'm going to replace it with a -3 plus 3. I know that a lot of us are going to want to cancel these guys, but you can't do that because that canceling, that's multiplication. You're multiplying a negative with a negative. But remember, order of operations says we need to do exponents first. So I need to tackle this guy first. -3 squared means -3 times -3. -3 times -3, this becomes a +9. Okay? If that becomes a +9 and I still have a negative in the front, then the final answer there is going to be a -9. On this next one, you have a -2 times a -3. That's going to give me a +6 plus 3. And now I have addition and subtraction, which I'm just going to go from left to right. -9 plus 6 is -3. -3 plus 3 gives me 0. So when I plug in -3, I get a y value of 0. I'm going to go ahead and plot that on my graph. We're going to go ahead and do the next one. This time I'm going to substitute a -2. Anywhere I see an x, I'm going to replace that x with a parentheses -2. So first I have that negative symbol, so I'm going to write y equals the negative symbol. Now I see the x, now I put a parentheses, and again, I'm going to replace that x with a -2 inside the parentheses, squared, minus 2 times, here's another x, so I'm going to replace it with a -2 plus 3. Just like last time, order of operation says I need to do exponents first. So I'm going to go ahead and do -2 squared. That means -2 times -2. This ends up being a +4. But because that's +4, when I put a negative in front of it, that becomes a -4. So I get y equals -4. -2 times -2, that gives me a +4 plus 3. Now it's addition and subtraction, so I'm just going to go ahead and add from left to right. -4 plus 4 is 0. 0 plus 3 is 3. So I get y equals 3. When I plugged in the negative 2, the answer I got was 3. I'm going to go ahead and plot that on my graph. Hopefully that made sense and you'd be able to do the rest of them. Let me just go ahead and give you those numbers to save time. When I substitute a negative 1, the answer I get is 4. So negative 1 comma 4 on my graph. When I substitute a 0, well, that's easy. This becomes 0, so it's gone. This becomes 0, so it's gone. And I'm just left with a 3. And then the last one, when I substitute a 1, the answer I get is 0. So let's see. I still need to plot 0 comma 3 and 1 comma 0. Let's take a look at what that graph is starting to look like. Most students would say it looks like an upside down U, and that is a very good description for it. So let's go ahead and draw an upside down U. I said it was a good description, which means you need to make sure that this is curved. Do not draw it straight. I should not see any straight lines as we're doing this. It should be nice and smooth. You should not be doing this with a ruler because, again, it's a U, okay? It has a curve. So it's going to say the graph is a parabola. When we say that U-looking shape, we call that a parabola. Since the graph is a parabola, I'm going to go ahead and highlight the word parabola. And I'm going to highlight the shape of this graph so that way we know, oh, that yellow thing means it's a parabola. On that parabola, there is a highest and a lowest point, just depending on whether the U is going up or going down. We call this thing a vertex. It is the very peak or the very dip of your parabola. So my vertex would be right here, this dot. Let me go ahead and put an arrow on it and say, this is my vertex. And I'm going to highlight the vocabulary word vertex so that way I know exactly what I'm looking at. What else do we know? Well, I know that this graph is symmetric. Hopefully that's a word you've heard before. Symmetric means that there's some kind of line that you can fold it on where the graph is going to fold on itself, or that the left side of the graph is going to be equal to the right side of the graph, or the top side is equal to the bottom side, or something to that extent, where it can kind of fold on itself and land on itself. So, for example, if I make a vertical line right here, we're going to call this the line of symmetry. Then everything on the left of the graph happens the exact same way on the right of the graph, right? Your line of symmetry doesn't have to be vertical. It might be horizontal. And in that case, the top of your graph would be the same as your bottom of the graph. Okay, let's keep going. Let's see. I got if A is greater than 0. We're going to kind of jam through this because this part we're going to get deeper into later. If your A value is greater than 0, so for example, this number right here, if that number is greater than 0, then technically you're going to have something that looks like this. We're going to say that this opens up. Let's get rid of that word is. It opens up. And like I said, if it looks like this, then there's going to be this bottom point here, which we call the minimum. That's this word right here. Conversely, well, that was a good word. Conversely, if your A is less than 0, then you're going to have something that looks like this, which means it's going to open down and your vertex is going to be up here, which means we have a highest value. And when we have a highest value, we say it has an absolute maximum. All right, that takes care of quadratic functions. Let's keep moving on. This next one we have is absolute value functions. Let me just remind you what absolute value does. Absolute value of a number means how many spaces it is from 0. So if I tell you the absolute value of -7, it's 7 because -7 is 7 spaces away from 0. The absolute value of -9 is 9 because -9 is 9 spaces away from 0. Where students start getting confused is when I start saying like the absolute value of 6. The absolute value of 6 is 6. It's not -6, okay? Absolute value of 6 is 6 because it is 6 spaces away from 0. So hopefully that kind of rings some bells up in your mind, and you're like, yep, I remember that. The standard form for absolute value is something I'm sure you have not seen before, but let me go ahead and give it to you anyways. F of x is equal to a times the absolute value of mx plus b. Forgot that about the m in the front. Mx plus b plus c. You're really going to focus on it next year. We're not going to worry too much, but you should know how to fill out a table. So how do I know if it's an absolute value? Well, you're going to see the variable x inside the absolute value. So they're going to have some long sticks like these ones right here, which means you need to take the absolute value of something. Oops. And you know what I forgot to do? I forgot to highlight the word absolute value. Those equations are going to look like this. Take a look at what those look like. You see how it has the absolute value here and the x is inside, absolute value here with the x inside, absolute value here with the x inside. Okay. All right, let's do a couple. I want to start graphing this. So I'm going to take my 0 and I'm going to plug it in wherever I see an x. So the first one's going to say y is equal to 2 times the absolute value of, there's my x. I'm going to replace it with a 0, minus 2, close the absolute value, and then minus 3. Remember that absolute values are a grouping symbol, kind of like parentheses. So we need to do the stuff inside the absolute value first. That means I need to do 0 minus 2, which is negative 2. So I get y is equal to 2 times the absolute value of negative 2 minus 3. Okay, here's where it might get a little confusing. At this point, I can take the absolute value of negative 2. Absolute value of negative 2 is just 2. So I'm going to replace that absolute value of negative 2 with just the number 2. That is to say, I'm still going to write y equals 2. But now, instead of absolute value of negative 2, I know that's just 2. So I'm going to put parentheses 2 minus 3. 2 times 2, that's going to give me a 4 minus 3. Y equals 1. So when we did all that work just to say when x is 0, then y is 1. 0, comma 1, I'm going to go ahead and put a dot. We're going to do one more, and then hopefully you'll be able to follow along on how to do this. We're going to replace the 1 anywhere I see an x. So I'm going to write y equals 2 times the absolute value of, there's my x, so I'm going to replace it with the number 1, minus 2, close my absolute value, minus 3. Remember, absolute value is like a grouping symbol, which means we need to do it first. That means I need to subtract 1 minus 2, which is negative 1. So I write y equals 2 times the absolute value of negative 1. I still need to write that absolute value because I haven't done it yet. I haven't said, oh, the absolute value of this is this, which is exactly what I'm going to do right now. There's nothing else inside the absolute value, so I'm going to take the absolute value of negative 1. Negative 1 is one space away from 0, so I'm going to say the absolute value of negative 1 is 1. Then I can write y equals to 2 times just the 1. I'm not writing an absolute value anymore. Minus 3. 2 times 1, that's 2 minus 3. And then 2 minus 3, I get a negative 1. So when I plug in a 1, the output I get is negative 1. All right, let me go ahead and give you the other values now that you kind of know how to do this. When I plug in a 2, I get a negative 3. When I plug in a 3, I get a 1. A negative 1. Sorry. And when I plug in a 4, I get a positive 1. Let's go ahead and plot those values. I already got 0, comma 1. That one's done. 1, comma negative 1 is down here. 2, comma negative 3 is down here. 3, comma negative 1 is here. And 4, comma 1 is here. We take a look and we say, what does that look like? And most students will say, it doesn't look like a U. It looks more rigid, so it actually looks like a V. And I would agree with that. Since it looks like a V, you need to make a straight line going through all those dots. And the same thing going in the opposite direction. So straight line. Make sure it goes through all the dots. All right, what do I know about this graph? Well, I know this graph is V-shaped. Since it is V-shaped, I'm going to highlight that it looks like a V. And I'm going to highlight the shape itself. this thing looks like a V, the graph has, well, this graph has two different slopes. We're not going to worry about that just yet, but just know it does have two slopes, one going down, the other one going up. What else? Just like before, this thing does have a vertex. The vertex is either the highest point or the lowest point of your graph, depending on whether the graph is pointing up or down. In this case, it looks like there's a lowest point on the graph, so my vertex must be here. And again, just like before, if it has a vertex, then it's probably going to have some kind of symmetry for the stuff that we're doing today, and that's exactly true. So we're going to say this graph is symmetrical. If it's symmetrical, then that means there's a line of symmetry. Let me go ahead and highlight that line of symmetry. Remember, the line of symmetry is the line where everything to the left is equivalent to the stuff on the right. And let me highlight the word symmetrical so we kind of get an idea of what that is. All right, and then just really quickly, if a is greater than 0, if this number is greater than 0 or if it's positive, then you're going to have a v that looks like this. And if you have a v that looks like this, then your vertex is going to be on the bottom, which means you have a minimum. There's a smallest value. So that's exactly what that says. If a is greater than 0, it opens up and has an absolute minimum. Well, then obviously, if your a is less than 0, then it's going to go the other way. And if it goes the other way, your vertex is up here. And if your vertex is up here, then this is the highest point, which we call the maximum. So your vertex would be a maximum in this case. If a is less than 0, then it opens down. And everything else we say is true. Okay. All right, last one. This one we're not going to really mess around with until Math 3. You're really going to start playing with these. But again, we're just going to get you exposed to them so you know what they look like. Standard form of this is going to be ab to the x. So let me go ahead and highlight that. Let's see. Exponential functions look like y equal to ab to the x. How do I know if it's an exponential function? This is the only one where the variable x is going to be used as an exponent. So for example, x is in the exponent, x is in the exponent, okay? Hey, on this one, we're going to do 3 of these because I just want to make sure that you understand what that is, okay? So let me go ahead and start substituting the 0 into this equation. I'm going to write y equals 2 to the 0 minus 4. I don't know if you know this, but 2 to the 0 is not 0. Whenever you raise anything to the 0 power, the answer is 1. So for example, 2 to the 0 is 1, 6 to the 0 is 1, 13 to the 0 is 1, 1,000 to the 0 is 1, negative 5 to the 0 is 1. And I kind of lied to you. Almost everything to the 0 is 1. The only one that doesn't work is 0 to the 0, and that one is undefined. It's kind of like if you try it on your calculator, it might say domain error, or it might say UD, undefined. But yeah, it's definitely an error. It doesn't work, okay? But anything else to the 0 power is 1, which means 2 to the 0 power is 1. And I can write y equals 1 minus 4. 1 minus 4 is negative 3. So when I plug in 0, the answer is negative 3. 0, negative 3. I'm going to put a dot. I said we're going to do 3 of these. Let's do the next one. Y equals 2 to the first minus 4. Remember, 2 to the first just means that it's 2 minus 4. And I get a negative 2. Okay, we're going to do one more like I promised. We're going to skip the 2, though. I want to go straight to 3. So we're actually going to work on this one, and then I'll give you the other answers. Let's see. Y equals 2 to the third minus 4. Be careful. 2 to the third is not 6. Remember, 2 to the third means 2 times 2 times 2. So let's see. 2 times 2 is 4. That takes care of 2 of them. Now for the third one, 4 times 2 is 8. So I'm going to write y equals 8 minus 4. And then 8 minus 4 gives me 4. Okay, let me just recap that again. 2 to the third means 2 times 2 times 2. That's 3 2s. The first 2 2s, 2 times 2 is 4. and then times another 2 gives me 8. Okay, so that's where that 8 is coming from. So that means when I plugged in the 3, the answer I got is 4. Sorry. And then let me go ahead and give you those other numbers. This one should have been a 0, and this should be a 12, which obviously is way off our graph, and we're not going to be able to graph that. That's okay. That might happen on the homework. It's fine. Okay, graph what you can. So I already graphed 0, -3. Let me go ahead and graph 1, -2. I can graph 2, 0, 3, 4. 4, 12 is way off my graph. Okay. I know what some of you guys are going to start saying is like, oh, that's starting to look like a U, but just hold off on a second, okay? With these kind of graphs, they look a little bit different. So do me a favor. We're going to do something kind of a little bit weird. Right at this -4, do you see this -4 down here? On that -4, we're going to draw a horizontal line going through it. So let me go ahead and draw a dashed horizontal line like this. Make sure it's dashed. And it goes on forever both ways. Okay, and now what I want to do is I want to make this kind of like, how would you describe it? Kind of like a slide that goes like this, and then it starts smoothing out, and it gets really, really close to that line that we just drew, but it doesn't ever touch. Man, I said it doesn't ever touch, and then I drew that it touched. Let me try to do better. I'm gonna go close, 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 but it doesn't touch. Ooh, that was pretty good. Um, So yeah, that's exactly the way you want to draw it. So as far as its characteristics, we're going to say that the graph is a smooth curve, but it's not a U. It looks like a slide. And so I'm going to go ahead and highlight the word smooth curve. And I'm going to highlight my picture as well to kind of show the shape of that smooth curve going on. Okay, what else? If b is greater than 1, then it's going to be increasing, and it is called exponential growth. What that's saying is, if this number right here is number larger than 1, then this thing is going to go up to left and right. Kind of picture like a roller coaster, and as you go to the right, it's going to be going up, okay? If b is less than 0, it's going to be the exact opposite. It's going to be like a roller coaster, but this time it's going to be sliding down like this. Picture someone right here, and they're going to be going that way. Okay, so if b is less than 0, it is decreasing, and it is called exponential decay. And then this is going to be a funny word. It says it has a blank. We're going to use the word asymptote. It has an asymptote. And that's a line that the graph approaches but never crosses. And that's exactly what's happening here. We are getting a line that's getting really, really, really close to this orange line right here, but it never really touches. It gets close, but it never touches. Okay, that's the notes for today. As always, if you have any questions, please feel free to ask.